All right, so let's begin lesson number 6 with a what do you notice, what do you wonder problem. Give yourself about a minute or two to write down all your ideas and then turn the video back on when you are finished. All right, so some possible answers you could come up with is that in both circles you have a right triangle. In the second quadrant, the angle measurement appears to be, theta, appears to be the same. Something else that appears to be true is that the triangle on the right might be, the lengths might be twice that of the triangle on the left because the scale factor might be 2 between the triangles. So again, you may come up with some others. A scale factor 2 idea is something of a wonder versus an actual fact, such as that the theta angle appears to be the same. The triangles are definitely right triangles. They're definitely in the second quadrant. So let's say, for example, the triangles really are similar. What would be the coordinate for problem or for point D? Again, if two triangles really are similar, what would be the coordinate of point D? Take a moment, figure that out, discuss that with your partner, turn the video back on when you're ready to continue. So to find the coordinates, since the triangle is definitely being scaled by 2, is to take each of the coordinates and double them. So that means the 0.5 becomes 1. And the negative 0.87 becomes negative 4.35. So we're taking each of these numbers again, and we are multiplying them by 2. Since the scale factor between the triangles is 2. So what if we would use, instead of an angle measurement, we'd use a radian measurement, and we're going to look at 3 problems here, 3 different circles. Write down, use again our sine cosine rule. Write down what the coordinate would be for P and for Q, and then I will show you a third one for R. When you're done with the first 2, turn the video back on, and we'll continue with that. So hopefully, for P, you wrote the cosine of 3 pi over 8 sine 3 pi over 8. That would be the coordinate of P for the first one. For Q, so we're doing a scale factor of 7. For Q, it would be 7 times cosine of 3 pi over 8, comma 7 times sine of 3 pi over 8. So, like the previous problem, when we changed coordinates, we multiplied both coordinates by 2 because the shape had been scaled. Here, we're going to multiply everything by 7, since the radius of the circle is now 7 times longer than the original. So, how about do the last one here? What if I make the radius 11? Turn the video back on when you're ready to check your coordinates for point R. So very similar to radius of 7, for R, it's going to be 11 times the cosine of 3 pi 8, comma 11 sine 3 pi 8. So again, we're taking the original answer, and we're simply multiplying both the x and y by 11. So hopefully you have received a handout from your teacher for lesson 6. And we're going to kind of pick up the same idea of what happens if I use a minute hand and the minute hand is length 11, what would be the exact coordinates at 45 minutes after the hour, 10 minutes, and 40 minutes after the hour. When you're finished discussing those and working those out with your partner, please turn the video back on. So since we're looking for the exact coordinates again, we're going to be looking at an answer that's going to be involving sine and cosine. So when I looked at this problem, here's where the minute hand would be at. This would be our basically our 0, or 2 pi. And this is pi on the other side. That would be at 45 minutes after. So that would be one of the times. And then the other one looking at is 40 minutes after, and the last one is at 10 minutes after. So the question I posed was how, as a count off between, say, 0 and pi, which is 1, you'll notice that, and up here, this is pi over 2. We're halfway there. So what am I basically counting off by? So I'm counting off by basically 6. So I'm counting off that. So it'll be 1, 2, 3, 4, 5, 6 to get to the 1. So basically, we're looking at counting off by 6. This would be pi over 6. This would be 2 pi over 6, which is pi over 3. This is 3 pi over 6, which simplifies to pi over 2. This is 4 pi over 6, 5 pi over 6, 6 pi over 6, which is just pi, and this is 7 pi over 6, and so on. So at 10 minutes after doing pi over 6, the exact coordinate would be the cosine of pi over 6 sine pi over 6. At 40 minutes after, 45 minutes after, we're looking at, this is the answer right here, which is on the 9th. This would be basic pi, so this would be cosine of pi, and then sine of pi. And then at 40 minutes after, we're looking at the clock's going clockwise, so 40 minutes after, it's going to be 7 pi over 6. So this would be cosine of 7 pi over 6 sine pi, 7 pi over 6. So in problem number 2, we're taking the same idea, except we're going from a 1-inch radius now to a 5-inch radius on the minute hand. So what would the answers be for those? So take a look at problem number 2, and while you're at it, take a look at problem number 3. We feel I've basically asked the same questions. I'm just changing the radius, real similar to the previous problems. And when you're ready to look at those 2 problems, turn the video back on. So we're basically starting at the same place we left off with a radius of 1. The difference now is that the radius is 5. So that means whatever the length is originally in terms of the x and y coordinate, now it's going to be 5 times larger. So that means each of these answers are going to be multiplied by 5. Because again, the radius has changed to 5. So to finish off first page, now the radius is 15, so that means the coordinates are going to be 15 times larger than the original. So these will both be 15 cosine and sine of pi, These will both be 15 cosine of pi over 6, 15 sine of pi over 6, and these will be 15 cosine of 7 pi over 6, and 15 sine of 7 pi over 6. Again, so just recap quickly, anytime you're changing coordinates and we're changing the radius of the circle, we're basically scaling the coordinates. So we're multiplying both the x and y by the value that we're using to scale from a unit circle to that circle. We're going to move on to page 2. All right, so go ahead and look at problem number 4. This time we're actually asking for how long is the minute hand if we know the coordinate. And then take a look at problem number 5 and see if you can figure out the answer to A based on the information given. Keep in mind that this problem is real similar to the ladybug problem when we're doing the clock in lesson 1 of this unit. Turn the video back on when you're ready to continue. All right, so to be able to find the length of the minute hand, to know the coordinates, we basically have a right triangle here where we know the x and the y, and we're looking for the radius. So we will be using the Pythagorean theorem to find that length. So these are both 56.25. So r squared would be 112.5. And then if I take the square root of that, the length is approximately 10.607 centimeters, I believe, inches. All right, so a couple critical numbers. We know we're 40 feet off the ground, so if I'm looking for the height, it's going to be 40 plus whatever the height or the distance is going to be within that Ferris wheel. We're looking at a radius of 30. So if this was simply a radius of 1, then we would be looking at the length of pi over 12. But because the radius is 30, that means it's going to be 30 times that. So since the distance going clockwise is this, and again the radius is 30, so we take 30 times pi over 12. So we get an answer that's approximately 47.854 feet. Go ahead and look at the other 3. Turn the video back on when you're ready to continue. Sorry about that. Just after I stopped the video, I looked at the problem and realized I left out sine. We are looking for a distance here in terms of above the y-axis, and then radians, and it should be 40 plus 30 times the sine of pi over 12, not just 30 pi over 12. So go ahead and make whatever adjustments you need to make in the answers, and turn the video back on. So the critical part about the sine, why it's important here, is because if sine's not in here, for example, the pi piece of it continues to increase. But if you think about when you do sine of pi over, or sine of the radian, you got to keep in mind that this is the peak, which is pi over 2. So we should not get an answer higher than 70. So this answer here is somewhere about 47, but as I get past the 5 over 2, I'm looking at 5 pi over 6 and 5 pi over 3, we're now coming back down, which means we're getting closer and closer to the 40 feet. That's why the answer is decreasing as we continue around it. I'm going to stop here for the first video, and I'll pick up in the second video with problem number 6.